Hi, welcome to the Physics 1 first semester final study guide. I'm going to go ahead and work through this study guide and hopefully you can use it to study for the final. This first video we're going to talk about this first scenario and I'm going to talk you through it. Hopefully you can understand what I'm going over and then we'll continue on to the next two scenarios. So here's the scenario. One day you wake up and find yourself living the life of a crash test dummy. Ah! It wasn't so bad until you had to do your job. At least you get a ride in the high-end, keep you so safe you can't move automobiles. This test has you traveling at the unnatural speed of 60 miles per hour, or 26.67 meters per second in physics land, towards a stationary sedan. A sedan is a small, compact car. The sedan is 21.54 meters west of you. You and your car have a combined mass of 794.7 kilograms. Alright, to start this off, I'm going to draw a picture. And so to start my picture off, I'm going to go ahead and draw my car. So here's my car that I'm sitting in. I look like that. And I'm going to label that me. Alright, and then over here I have my sedan, which is a small car. Put it there, and I'm going to label that sedan, or said. Alright, now there's some things I need to pick out from my scenario, such as I am traveling at 26.67 meters per second. The sedan is 21.54 meters west. And we have a mass of 794.7 kilograms. So if I were to label this, draw me an arrow on that right there. I will say that that distance right there is 21.54 meters. I would also say that I have a velocity right here going in that direction of, and in this case it's going to be 26.67 meters per second. And so I'm going to call that my velocity 1, or my velocity at the beginning. 26.67 meters per second. I know that my car has a mass of 794.7 kilograms. Okay, so now that I have all of these things picked out of our scenario, I need to go ahead and answer the first question. The first part of this test is the test of brake efficiency. When the brake is pushed, we're going to assume that the tires lock up and the car skids on the surface between the tires and the road. And so the car is going to decelerate at 14.38 meters per second squared. All right, let's go ahead and highlight that. 14.38 meters per second squared, which is an acceleration. What is your velocity right before you strike the sedan? So here's my velocity at the beginning. I want to know what is my velocity at that location right there. Velocity question mark. For this one, I know acceleration equals 14.38 meters per second squared. And then I also know a direction, even though it doesn't tell me, because my car decelerates, which means it slows down, it has to be in the opposite direction of my velocity, which is going to be east. East. This is west. All right, and it points to the west. Now I know it looks like my directions are backwards, but I'm assuming that to the right is to the west and to the left is to the east. So now I have my acceleration. I have a velocity 1. I'm looking for a velocity 2, or a final velocity, and I know the displacement, or my delta x. I'm going to use the equation v final squared equals v initial squared plus 2a delta x. And the reason why I'm using this equation is because if I look here, I have v initial is what it's asking me for. I have that up here. I start my braking at this velocity. I also have an acceleration. It is given right here. So this is the acceleration during that period of time that I'm looking at it. And then my delta x is going to be this number right here. The distance that I travel to where I'm just right before I hit the sedan. So now all I have to do is plug in my numbers. V final squared equals my V initial squared, which is 26.67 and that's going to be squared plus 2 times my acceleration, which is 14.38, right? And that's negative because it goes in the opposite direction, and so I'm assuming that it's going to be negative, because if my velocity is positive, then my acceleration has to be going in the negative direction, times my delta x, which is 21.54 meters. Now, whenever I do this in the calculator, it'll give me my answer. Now, once I type this into my calculator, it's going to give me my v final squared. So in order to get my v final by itself, I have to square root both sides, and I get v final equal to 9.581 meters per second, and we're going to the west. So we have slowed down to this speed right here. So at this location, and I'm going to highlight that in this color, this v final right here is that location. So that's my velocity at that location in my scenario. Now, number 2 says, what is the normal force on my car? Well, if I were to draw my free body diagram, there's my dot. Well, I have the force of gravity that points down, F sub g. I also have the normal force that points up, F sub n, and I know I also have the force of friction between the ground and my tires. And those are the only forces in the scenario. And actually, let's go ahead and erase these. I'm going to make a better line. I have F sub n, and then I have F sub g. And I know that my normal force, F sub n, equals F sub g cosine theta. Well, my angle theta is the angle between the horizontal and my surface. Well, because my surface is horizontal, theta is 0, and that means that that whole thing is just 1. So my normal force is going to equal my force of gravity, which also equals my mass times the acceleration of gravity. So in this case, Fn is going to equal my mass, which is up here at 794.7, times the acceleration of gravity, which is 9.81 meters per second squared. And whenever I type that into my calculator, I get 7,800 newtons. Okay, number 3 says, what is the force of kinetic friction between the tires in the car? Now, a lot of people ask me, well, how can I find that? I don't have the coefficient of kinetic friction. Well, you don't need it in this case, because if I look at my free body diagram right here, my net force, which is the sum of all the forces, well, my F sub g and my F sub n are going to cancel out. And so really what I'm left with, my net force on my car is my force of kinetic friction. I also know that the net force, F net, equals ma. So because my net force equals my force of kinetic friction, and I know the acceleration of my car as being 14.38 meters per second squared, and the mass of my car being 794.7, the force of kinetic friction equals 794.7 times my acceleration, which is 14.38. And in this case, I get my force of kinetic friction as 11,430 newtons, and in this case, it's going to be to the east. Okay, so there are those 2 questions. So what we have the force of kinetic friction now. We also have the force of normal force, and so this asks us what is the coefficient of kinetic friction, and we know that mu sub k equals F sub k divided by Fn. So this is another equation that we had. So I just take my F sub k, which is 11,430, and I divide it by 7,800, and I get a mu sub k of 1.47, and there are no units involved in this. Okay, it says, what kinetic energy does the car have before the collision? Well, in this case, kinetic energy equals 1/2 mv squared. If I were to go up here, my velocity right before I hit the car is 9.581 meters per second to the west. So it'll be my velocity. So 1/2 794.7 times 9.581. And that number is going to be squared. And so I get my kinetic energy equal to 36,000 470 joules. Okay, question 6 says, if it takes my car 0.975 seconds to come to a complete stop, what is your car's acceleration? Well, I know in this case my final velocity is going to be 0. Now, this is during the wreck, so I need to know my initial velocity whenever I go into the wreck, or before I undergo the collision. And that initial velocity is 9.581 meters per second west. Okay? Acceleration is what I'm looking for, and my time equals 0.975 seconds. So in this case, I'm just going to use the simple acceleration equation, v final minus v initial all over t. So in this case, v final is 0 minus 9.581 all over my time, which is 0.975. Whenever I do this, I actually get a negative number, a negative 9.83 meters per second. Now what this means is it means that this negative sign that's right here, and I'm going to go ahead and move it up so it's in line. What that means is that I'm actually traveling in my negative direction, which is 9.83 meters per second east. And that's my answer. And then the last one for this scenario is, what is the force exerted on me? Well, in this case, if I'm attached to the car, I'm going to have the same acceleration as the car. So that means my acceleration is going to be 9.83 meters per second squared east. So let me fix that up here. And I want to know my force that's on me. And so using Newton's second law, F equals ma. Well, my mass is 83.7 kilograms. My acceleration is 9.83 meters per second squared. And I get 823 newtons pointed to the east. All right, and that's the end of the first scenario. And tune in for the next two scenarios.